Hey, algebra. We are continuing on to lesson 11, graphing from the factored form. We've done that a little bit in the last lesson because I tend to get ahead of myself, but here we will graph. So here is a graph of a function w defined by w of x equals 1 plus 1.6. W of x equals x plus 1.6 times x minus 2. How we should really say that is the quantity x plus 1.6 times the quantity x minus 2. 3 points on the graph are labeled. So find the values of everything. Be prepared to explain your reasoning. So I know that this is an x-intercept and that's an x-intercept. And I get those from right here. So I can say that x plus 1.6, if I'm solving that for 0, because the solutions are called the zeros, I can say x equals negative 1.6. So that is negative 1.6 comma 0, because the y value is 0 at that point. So that is going to be A and B. Now I can take the other part, which is x minus 2 equals 0, and solve that for x. X equals 2. So that means that when x is 2, y is 0. And that is going to be my c value and my d value. Now, how about the y-intercept? We know the y-intercept is the constant of standard form, ax squared plus bx plus c. And I get that constant by foiling the last two terms, last times last. 1.6 times negative 2 is negative 3.2. Now I get that negative 3.2. It's a constant when x equals 0. So 0 comma negative 3.2 is going to be my e and my f term. I've said zeros a lot. So these are considered the zeros. It's the solutions. They're called the zeros. They're called the solutions. And they're where y equals 0. What is my x? And over here we have the y-intercept, which is also the constant. Oops. And it's when x equals 0. What's the y value? Okay, I know that's using the word 0 a lot, but you guys will get it. All right, comparing two graphs. Consider two functions defined by f of x equals x times x plus 4 and x times x minus 4. Rewind. I should really say x times the quantity x plus 4 and x times the quantity x minus 4. So complete the table of values for each function. Then determine the x-intercepts and vertex of each graph. All right, I'm going to push pause and fill this in because you guys can do this part on your own, okay? So you're just plugging in the x values into this equation, and then you're plugging in the x values to that equation and filling in the table, all right? So push pause and fill in your own table. Cool? Be right back. All right, I filled in the table and I put some arrows by some things. So we learned that the x-intercepts are the x values when y equals 0. So the x values when y equals 0, negative 4 right there, and 0 right there. And then the vertex is when x equals 0. No, not the vertex. Sorry, that's the y-intercept is when x equals 0. Sorry, let's erase this. So we have the x-intercepts are when y equals 0, and the vertex is going to be either your highest point or your lowest point. Or what's really cool is it's halfway between the x-intercepts. So that right there is our vertex. We'll keep it in red and go negative 2 comma negative 4. The vertex is the highest point or the lowest point in a graph. All right, so here in green, we have the x-intercepts as where y equals 0. I guess I should say, remind you guys that that's my y. My x-intercepts are 0 and 4. And then my vertex is halfway between those two x-intercepts, right there. Or it is 2, negative 4. Okay, now we're going to need this information on my next slide, so let me take a picture. All right, here it says plot the points in the table from the tables on the same coordinate plane. Okay, consider using different colors or markings for each set of points so you can tell them apart. I'm using blue for f of x and green for g of x. Then make a couple of observations about about how the two graphs compare. All right, so I'm going to push pause again and do some graphing. All right, that's pretty cool. I see in blue, I've got my x-intercepts of negative 4 and 0, and my vertex of negative 2, negative 4. And in green, I have my x-intercepts of 0 and 4, and my vertex of 2, negative 4. It looks like they are exact reflections of each other. Pretty cool, huh? So that's my observations. X-intercepts of both happen at 0, 0, right? The graphs are reflections of each other across the y-axis. The vertexes both have a y-coordinate of negative 4. A y-coordinate of negative 4 for the vertex, but they're reflections across the y-axis. All right, those are my observations. That's pretty cool. All right, last slide. If we look at what do we need to sketch a graph? So the functions f, g, and h are given. Predict the x-intercepts and the x-coordinate of the vertex of each function. So here my x-intercepts are going to be negative 3 and 5. So the x-coordinate of the vertex is going to be halfway in between. So the distance from negative 3 to 5 is 8. So the distance from negative 3 to 5 is 8. Half of 8 is 4. So I want to go halfway in between negative 3 and 5, which is going to be a value of 1. All right, let's try this next one. My x-intercepts are going to be 0 and positive 3. The distance between 0 and 3 is 3. Half of that distance is 1.5. So that's actually going to be my x-coordinate of the vertex. For h of x, I actually have x plus 4 and negative x plus 4. Okay, that negative, well, we're going to leave that there. That's h of x. So if I take each one, I have x plus 4 equals 0, so x equals negative 4. Or negative x plus 4 equals 0. Here I have x equals 4. So as silly as that one is set up, you can still work it the same way. So I get a negative 4 and a 4. Okay, the distance between negative 4 and 4 is actually 8. Halfway between that distance is 4, so my x-coordinate for the vertex is going to be a 0. All right, use graphing technology to graph the functions f, g, and h, and use the graphs to check your predictions. I'm going to do that on Desmos and start a new slide. If you would like to play along, go ahead and open up Desmos. All right, let's look at this. F of x is in red. We had a y-intercept of negative 3. Oops, did not mean to do that. There we go, of negative 3 and positive 5, and a vertex, an x-coordinate for the vertex of 1, which is right there. Cool, and that I should have made all those marks in red. Cool, and g of x is in blue. I had x-intercept of 0, an x-intercept of 3, and an x-coordinate for the vertex of 1.5, which you can see right there. And then green, I had a negative 4, a positive 4, and an x-coordinate for the vertex of 0. They all worked out. And that was the last slide. Oh wait, without using technology, sketch a graph that represents this equation. So I'm going to have an x-intercept of positive 7, somewhere around there, negative 11, somewhere around there. Then the distance from 7 to 11 is actually 18. Divided by 2 is 9. Now how can I figure out where that point is? If I'm at negative 11 and I want to travel 9 in this direction, I'm going to get to a negative 2. If I'm at a 7 and I want to travel 9 in this direction, I'm going to get to a negative 2. So that's where my point is right about there. Okay, everything is positive. I have a positive leading coefficient, so I'm going to have a happy parabola. So my sketch is something like that. We just don't know where the vertex is, how far down or up it is, but we know the line of symmetry through the vertex, where that x coordinate of the vertex is. All right, good job.